Okay, so your task was to create 4 different representations of a proportional relationship. Okay, so write that same relationship in 4 different ways. Just think of it as 4 different languages. Okay, but they all mean the same thing. So let's go to the first one. So here is a statement, right? So we can write it. The represent proportional relationship as a sentence, as a table, and a graph, and an equation. So I'm going to repeat this in 3 different ways. So let's look at a table. Now on the table, you have your x and y coordinates, your order pair. And here, we're going to write hours. And here's the amount of money you take home, right? So, and the only thing that I have now is that if you work 1 hour, you make 12 bucks. And we can fill in the table with other values. Pick some random ones, 0, 0, 2, 24, 3, 36. And right off the bat, right, we're given this guy is a unit rate, right? And it's also our constant proportionality. Right? It's the ratio between the y and that. So if I take y divided by x, I will always get 12. So 12 divided by 1 is 12, 24 divided by 2 is 12, 36 divided by 3 is 12. So times 12, times 12, times 12, etc., etc. Okay. So that's as a table. So I'm representing that statement as a table. On the graph, right, we're only going to use the first quadrant here because we don't need the other ones. And we can represent x here, that's my hours. Y here is the amount of money you take home after you work a certain amount of hours. And let's just put the values that we have on the table. 1 hour, 2 hours, 3 hours, 4 hours. So, and that y value, we're going to go by 12. If I work 1 hour, I make 12 bucks. If I work 2 hours, I make $24. I've worked 3 hours times 12, 36, 4 hours, 48, and so forth. Should I connect these thoughts? Well, I guess it does make sense, because what if I worked, I don't know, an hour and 10 minutes? I would get paid whatever value that represents, maybe $13 or so. What if I work an hour and a half, which is this value? I get paid 18 bucks, which is this point right here. So is it possible? Does these other points, these other pairs make sense? Yeah, it does. What if I work 5 minutes? What if I work 10 minutes? Nobody works for free. So this relationship is linear, meaning it's a straight line. And sorry, mine doesn't look like a straight line, but it should be a straight line. Right? Where's my unit rates? Right here. This is my unit rate. The order pair 1, 12. 1 hour I work, I make 12 bucks. This is my unit rate. 12 is also my constant proportionality. What's my equation? Well, my equation comes, proportional equation comes in this format. In this case, y represents the amount of money I take home. The x represents the number of hours that I work. And k, in this case, represents the amount per hour. So let's actually give me the equation. Well, y equals 12 times x. And you know now what each of these 3 represents. Okay. So we're going to repeat this with different scenarios. So here is a table. It doesn't give us any context, so I'll just make one for every, for every, let's call this days, and let's call this trees. For every 1 day, I plant 3 trees. So the sentence, for every day, or 1 day, I plant 3 trees. Here's my graph. Can you find a constant proportionality? Can you find the unit rates? Right here. Right here, right here. Here's my unit rate. Right? 3 is also my constant proportionality. Notice that if I take any of these order pairs, right, and I divide y by x, 3 divided by 1 is 3, so 3 over 1 is 3, 12 over 4 is 3, 15 over 5 is 3, so there it repeats over and over, right? So there's my constant proportionality. So if I worked 10 days, how many trees did I plant? 30, right? So, and that's that. Graph, how does a graph look? Well, two things. One, I know it's going to be a straight line, and two, it's going to go through the origin. Right, so x is the number of days. Y represents the number of trees that I plant. So 1, 2, 3, 4, 5, and then the y-axis, let's go by threes. 3, 6, 9, 12, 15, and so forth. So 1 day, 3 trees, 2 days, 6 trees, 3 days, 9 trees, 4 days, 12, 5 days, 15, and so on. Can I connect the dots here? Does it take me 1 day to plant 3 trees, or is it, what if I work half a day? Does that mean I planted 1.5 trees? Is there a context to that? Does that make sense? What if I work 1 3/4 of a day, right? Not exactly 24 hours. What if I work 19 hours? Does that mean I planted 2 trees and whatever, and 2/3 or something like that? So this one I'm not going to connect. Okay, because the context I don't think is there. So still, if you were to connect, it would be a straight line, right? And it would go through the origin because it makes sense that 0 days, I plant 0 trees. Where's my constant proportionality? Can you locate it on the graph? It's right here. This pair, this order pair, 1, 3, it's my unit rate. And 3 is my constant proportionality. What's the equation look like? Well, the equation, remember, comes in this format. Sometimes they're going to ask you to use different letters, and I'll get to that in a second. So y, so instead of y represents the trees, right? So instead of y, I can use the letter t, the number of trees that I plant. K, in this case, is 3, we know that. And x represents a day, so instead of x, I'm going to call it d. So whether you use that or you use y equals 3x, it's up to you. It depends on the question. So again, whether you use t or y, that represents number of trees. X represents number of days. And the 3, well, it is your unit rate, it is your constant proportionality, but in the context of this, it represents 3 number of trees planted per day. That's what that 3 represents. That's it. That's literally it. This one, a little different. Let me write ounces, and I have no idea if this is true or not. I just made it up. I have a point on the graph that says, hey, 4 tennis balls is 6 ounces. So let me just write 1, 2, 3, 4. So 3 measures this many ounces, 2 is this many ounces, and 1 is this many ounces. Notice that I don't know. I want this. It's 1 comma something, right? I want to find the constant proportionality. I want you to identify the constant proportionality. I want you to, or the unit rate, right? So we can go to the table, right? Since we have to fill 1 anyway, and I put the 1 relationship I know. If I have 4 tennis balls, and I'll write tennis balls, they weigh 6 ounces. So let's fill in 1, 2, 3. Well, how do I find my constant proportionality? I'm going to take the only order pair that I have, the information that I have, which is 4 and 6. I'm going to divide 6 divided by 4, and I get 1.5. So there is my constant proportionality, my unit rate. So if I go here to 1, it's going to be 1.5, right? So let me change colors here. So 4 times 1.5, 1 times 1.5, 2 times 1.5, 3 times 1.5, and let's fill in the table. So 2 would be 3, and then 3 would be 4.5 ounces. There. Where's my unit rate? It's right here. On the table, it's right there. 15 unit rate, and 15 is my constant proportionality. not 15, 1.5, sorry, and 1.5 by cost proportionality. All right, so now I can go to the graph, and I actually have values. So 1 tennis ball gives me 1.5 ounces. So this is 1.5. 2 tennis balls would be 3 ounces. 3 tennis balls would be 4.5 ounces. And then 4 tennis balls that we had originally, look, 6 ounces. So, with a big dot there, identify your constant proportionality, which in this case is 1.5. So notice that this table, written as a graph, looks like that. What's my equation? And again, y equals k times x, where y represents the weight, total weight in ounces, X is going to represent the number of tennis balls. And K, our constant proportionality, represents the weight per 1 tennis ball. That's our unit weight. And we know what K is. K is 1.5. So our equation equals y equals 1.5 x. Yeah? Next one. Okay, so this now we have the equation, and we need to fill the other one. So I think I said that t is a time in minutes. D is the distance in miles. That's what okay, so based on that, right, so this would be what? Distance, so 5/4 distance traveled in 1 minute, right? That's what the 5/4. But you know what? I think it's easier. 5/4, I'm going to change that to 1.25. So if you had the equation D equals 1.25t and you want to use that, or y equals 1.25t, x, sorry, you can use that. So it's up to you. Well, let's go to the table here, right? And I know what the constant proportionality is, right? So it's 1.5, and that's my unit rate. So I can go here and write 1 and 1.25. I know that relationship, right? So everything's going to be multiplied by 1, because that's the unit rate. Right, so times. What if I had 2 minutes? Well, I would go 2.5 miles. 3 minutes, it'd be 3.75 miles. What if you traveled for 4 minutes? It'd be 5 miles. X represents the minutes, I forgot. And Y represents the miles that you travel. So, can you write this as a sentence? Well, here we go. For every 1 mile, for every 1 minute, I travel 1.25 miles. There. So from the equation, right, once you understand what the equation stands for, you can create a table, and we're going to create a graph right now. So 0, 1, 2, 3, 4, etc. So 1 mile, 1 minute, I go 1.25. 2 minutes, I go 2.5 miles. 3 minutes, I go 3.75. And 4 minutes, I go 5 miles. Here's my points. Should I connect the dots? Well, I think in this case we can. So what if I travel 1 minute and, I don't know, 30 seconds, a minute and a half, which would be right here, 1.5. Would I travel this distance right here? Right, I would. Right, so each of these, can I travel 10 seconds? Can I travel 11 seconds? Can I travel 30 seconds? Can I travel 2 minutes and 5 seconds? I can. And for all those distances, so all those time, I would have a distance, right, that corresponds to that particular time, and I can use. So let's say I traveled for a minute and a half. Well, multiply that by 1.25, and you would get, Alexa, what's 1.5 times 1.25?
1.5 times 1.25, 1.875.
That's how much in miles I would travel. So all these other points, right, do make sense. So therefore, with this one, I'm going to connect the dots. So I connect the dots, a straight line that goes through the origin. What's the equation? I'm going to give this line a name. The name of this line is y equals 1.25t, x, or d equals 1.25t. Different versions of it, right? So the fraction, there we go. They all mean the same thing. So for this one, I went from the equation. I created a table. From there, I represent the table as a graph. And I forgot to do one thing, which come here. Here's my 0.1, comma 1.25. And that represents what? The 1.25 represents my k, and it's my unit. Next one. Okay, so this did give some of you a little hard time. There is a graph. And on this graph, there's a point. Well, first of all, it's proportional. So it's proportional, I know two things. A, it's going to be a straight line. B, it's going to go through 0, 0. Right? And there's a point right here, 5/4, comma 7/10. Right here. Let me put it right here. Okay? They're asking us, are these other points on the line as well? Right? So, what does that mean? If they're on the line, let me create a table. And on that table, let me create the one point that I know for sure, 5/4. And then when x is 5/4, y is 7/10. So they're asking us, and I'm going to change colors, is 12.5 and 10, is 2.5 and 1 2/5, is 20 and 17.5, and finally, they have 0, 0. I'll do that in a second. 0.625 and 0.35. So are these other points, right, B, C, D, E, on the line, or are they here? Right? Not on the line. If they're on the line, that means that they share something, the same constant of proportionality. Well, 0, 0 is obvious. That's a yes. Why? Because this is a proportional relationship, so it must go through the 0, 0, 0. So we know 0, 0 is there. Is 12.5 and 10 on this line? Do they have the same constant proportionality? Well, you're going to need to take the calculator and figure out the constant proportionality. So that's exactly what I'm going to do. Take a calculator, and then let's find the constant proportionality here. So if I were to ask you, find the constant proportionality here with the point, the original one, you would find k is y divided by x. In this case, k, I'm going to take 7/10, and we're going to divide that by 5/4. So if you took the calculator, and you did that, 7/10, and you divide that by 5/4, you would get 14/25 times 14/25. You can change that to a decimal, okay? And if you change that to a decimal, it's 0.56. So our point, our original point, the constant proportionality was 14/25. So that means that this should be times 14/25. This means that this should be 14/25, and this should be 14/25, and this should be 14/25. If it is, then that point, right, is on the line as well. So let's check the first one. 12.5 times 14/25, is it equal to 10? No, it's not. It actually equals to 7, so no. Second one, 2.5 times 14/25, is that equal to 1 2/5? Yes. This one is a yes. But this won't work. 20 times 14/25, is it 17.5? No, it's actually 11.2. So is that? That's a no. This is wrong. This is wrong. And then the last one, 0.625 times 14/25, or 0.56. Is that equal to 0.35? Yes. So we have 3 points, and I'm going to highlight them. This guy here. So 0, 0, C, and the last one. These 3 are on the line. How do I know that? Because they share the same constant proportionality. Okay, same ratio between the y value and the x value. And that's that. So if you missed because you were taking the specialized high school test, or you were away, or for whatever reason, depending on the class that you are, that's what we did.